Okay, friends.
Yeah, I love that.
I know.
He's like, you have to get your grades out. She showed me her grades. She has straight A's, only missed 2 days. Really long.
I'd be
So pissed. But she's excited because it's more relaxed. Jake
All right.
is so much more relaxed and it's so much more fun.
We are gonna kind of multitask today. So I'm gonna. This lecture is pretty quick, and hey, I gotta tell you, the quiz on Monday. Cake walk. Cake walk. I am serious.
Yeah.
So I made it worth 190 points because it is that much of a cake walk.
No, he didn't.
That's how lamb. Sunday, baby. Sunday video on my own. That's what I'm saying.
Because what I'm feeling right now is not
Jeez, you know you gotta. So you got. I was walking to some grand meeting.
All right. Let me lecture on this stuff quick, and then everyone's gonna grab a Chromebook and we're gonna go through that sleep survey if you haven't done it yet. Of course, you can do it on your phones if you wanted to.
I don't sleep.
You don't sleep good, dude.
Thank you.
When Grant comes,
Huh?
that's for Grant. Okay.
Grant's not coming. Yeah, he was going another way.
He's doing it another way.
As I was walking here, I just walked right past him. He didn't hear that from me though.
I didn't hear it. All right.
There he is.
No, Miwa. All right, does everyone have notes? Is
Pizza.
everyone back on Miwa's desk? Yeah, I think so.
Grant's
All right.
always on excuse.
All right. So yes, please know this, that Monday's test is. I really do think it's a walk in the park. We give you the
Give us
formulas.
the formulas.
Yes.
I
They're on the front
only
page.
worried about his memories of the concept.
Huh?
I was only worried about memorizing the formulas.
I wouldn't worry about that.
That's so easy.
All right. So let's talk about a graph that actually has shifted right left that we want to find the equation to. So I'm gonna start out with excuse me, my equation. So let's label it obvious things. I know -4, agree? And it's growth. So my B value is going to be a value that's bigger than 1. And then we do have a shift. So let's take a look. So remember, we want these to be 1 apart from each other. Are they 1 apart in the x direction? So how far is -3 to -4?
1.
1. And how far is it from -2 to -4?
2.
2. Okay? Everyone good so far? So my B value is automatically 2. I'm not going to worry about the A value. Okay? Then, last thing we just want to double check. That point that is 1 above the asymptote, how far is it from the y-axis? 3. So it's a +3. So I'm going to make that a -3. Done. Cool? Make sense?
Yeah. Yep.
So I do it the exact same way, but then I have to think about what was my closest to the asymptote and how would I move that to the y-axis. So next one, it's a decay problem, agreed? The reason it's decay is because as it goes to the right, it gets close to the asymptote. So again, I'm going to use my equation. So my asymptote on this one is just 0, okay? So we don't necessarily have to put it, but we'll put it anyhow. And then how far is this point? That's 1 from the asymptote. How far is that from the asymptote? And it's 3. So it's decay. So I can't go with 3. I have to go with what if it's decay?
1/3 or negative?
1/3.
Yeah, it's 1/3 or 3 to the negative 1. So I'm going to make my B value 1/3. My A value I'm not worried about. How far is this value from the y-axis?
3.
It's 1, 2, 3. This value right here.
And 3.
It's 3 away.
Yeah.
Okay. It's -3, so I'm going to go plus 3 here. So I guess my overall equation I could list it like this. I would take either one though. I think they're both 100% appropriate. Questions so far? Are we good? Yay. All right. What powers of 2 do we know quickly? Well, 2 to the 0, 2 to the 1, 2 to the 2. We all know those pretty quickly, yes? Okay. If you see a fraction on these, realize I could make fractions the same thing as a negative exponent. So this could become 2 to the negative 1. So this means this is -1. Okay, I'll say that again. If I know that I have fractions, I could make this 32 to the negative 1. Let's put 32 as a base of 2. So 2, 4, 8, 16, 32. So 2 to the negative 5th. So what goes here? -5. Okay. How do I make that 1/2 so it would be a positive exponent? How do I make that 1/2 have a positive? How do I flip it around, make it have a positive exponent?
Negative.
So this has got to be a negative. Okay. All right. Now let's figure out 2 to the 64th. 2, 4, 5. So 2, 4, 8, 16, 32, 64. So this is a -6.
Wow.
So 1/2 to the -6 power is the same thing as 2 to the 6th power, and 2 to the 6th power is the same thing as 64. Okay, so 64 is also 2 to the 6th. Okay?
Wait, the second one is that -5?
-5 in there, yeah. Because 2 times itself 5 times gives me the 32. Okay. So 3 to what power is 81? 3,
9. 4.
4.
4. Why is
Okay, it's a fraction. What would flip the fraction over?
-4?
Make it a -4. So 3 to the 4th power is 81. 1 over 3 to the negative turns to 3 over 1, which is 3. 3 to the 4th is 81. What about this one?
-2.
It seems like it should be a -2. Do you agree?
1/2.
It seems like a -2.
Positive.
It seems like a -2. But can I raise an exponent, a number to an exponent, and make it negative? I can make it a fraction, but I can't make it negative, so this one has no solution.
Oh.
That's a, catch you off guard.
Would it actually be 1/4?
What do you want the next one to be?
Is it 1/4? I don't know.
1/4? It's real close. So let's make 81 a base 3. So base 3 to the 4th power is 81. And then if I wanted to flip it over, if I want to flip this 3 over, I'd make it
the same question as 1.
What did I do?
No, it's different.
It's the exact
Yeah, it's
same.
the
Oh, exact same. Good eye. Good eye. All right. Can I raise a number, a negative number, to an exponent and it comes out negative? I can. It has to be an odd number, right?
Yeah.
Okay. So let's see. Let's figure out how to get to 128 from 2. So 2, 4, 8, 16, 32, 64. So that's 6, 7. So -2 to the 7th power is indeed 128. If I multiply -2 times itself 7 times, -2, -2, -2, -2, -2, -2, and -2, I get to -128. Questions there? Everything good? All right, so now we want to evaluate these. So I have negative 5/3 to a negative 3. So that I could rewrite this as negative 3 to the 5. It still stays negative to the third. Negative times negative times negative is? 3 negatives in a row is negative. 3 times 3 times 3 is 27. 5 times 5 times 5 is 125. Agree? So 2 to the 5th power is 32, but I want to make sure it's a fraction, and I don't have a negative exponent, so I'm going to go 1/2. So if I go 1/2 times 1/2, I get 1/4, times another 1/2, 1/8, times another 1/2, 1/16, and times the 5th 1/2, I get 1/32. What should I do with 7? It's a negative exponent, so what does it do? Flips. So I get 6/5. 6/5 squared is 36/25. And then, number 8. Can I multiply a number times itself 5 times to get a negative number?
Yeah.
Yeah, it needs to be a negative number, right? So this is going to be a negative 2. Because 2, 4, 8, 16, 32, 2 to the 5th. Or negative 2 to the 5th. Or 1/2, negative 1/2 to the 5th. Okay. Let's see. Can I make this a negative 2? And my answer comes out. To be a negative answer. Can I square a negative and get a negative answer? No. So that's a no solution. Okay. 1/216. We have to realize that 6 to the first, 6 to the second, 6 to the third. So 6 to the third is 216, but I have 1/216, so what should that be? Negative what? Third. So negative third power. Okay. I have to know my things so 5 to the first, 5 to the second, 5 to the third. Okay, so 5 to the third. What do I have to have x equal to get me 1/25?
7,600.
7,600, pretty close. So we got to make it to the negative 3. That means I would, if it was 5 to the negative 3, I'd flip over 5, make it 1/5. Then I get 1/5 to the third power, which is 1/5 times 1/5 times 1/5. Okay. Ooh, this one's a little bit of a gotcha. It might be easier for you to realize this. Agree? Okay, so that means that this x needs to be a negative. And then I wanted to flip it over. And it's not negative 3. What? Negative 1/3. Why is it 1/3? Is the 1/3 power the same thing as the third root?
Oh, yeah.
Yeah, so you have to realize that the third root of something, so the third root of x to the first is equal to x to the 1/3. So that's important to see. So leave that for a moment. Other questions? Happy so far?
Always happy.
Love it. All right. So this one, it's sometimes easier to take it down to its smallest base. So maybe I would write 25 to the x to be 5 to the 2x. Is that okay, first off?
Yep.
And then I have 1/25, so I'm going to make that 5 to the third. But then I'm going to make it 5 to the negative 3. Why did I make it 5 to the negative 3? Because on the right, it's now 1/5 to the third, right? So over here, it was still this. And then if I move this up, I get the negative 3. And then what do you think I do with the exponents? Can I set them equal to each other if I have like bases? Yep, I have like bases, so I'm going to say, 2x is equal to negative 3. So x equals what?
X equals negative
3/2.
Yeah, you guys had a good Algebra 1 teacher. Yay.
Miss Reyes.
Yeah, Richardson.
Mrs. Green.
Miss. Your recollection is crazy, Mr. Smith.
Mrs. Green was babylicious.
That was babylicious.
Babylicious. All right, so I want to turn 27, and I also want to turn 9 to be in the same base. So can I change 9 to 3 squared? And can I change, first off, I want to flip this over. So if I did 27 to the negative x, is that okay? Is that the flip over that? 27 is the same thing as 3 to the third power. So I get 3 to the negative 3x. Now I have like bases. I set the exponents equal to each other. So I get x is equal to negative 2 over 3. Does that seem okay? And I can convert 216 to 6 to the third power. Agree? Because 6 times 6 times 6 is 216. So this becomes, I'm going to change that to 6 to the third. And then that's going to be times this. So that means I have 3x minus 9 equals, and then I'm going to change this to 6 to the negative x. Right, I flipped it over, so it becomes equal to negative x. If I want to solve for x, if I subtract 3x from both sides, I get negative 9 equals negative 4x. So x has to equal positive 9 over 4. Agree?
Yep.
I want 4 and 8 to become the same base, so I'm going to take 4 down to 2 squared. So this is going to turn into 2 squared and then 3x minus 4. I'm going to flip this, so this is going to become 8 to the negative 2x. Now I don't have it as a fraction. Agree? Change 8 to 2 to the third. So this is going to change to 2 to the third times negative 2x. Same basis, so set the exponents equal to each other. Do your little bit of algebra that you remember. Okay, if I subtract 6x from both sides, so x is equal to 8 over 12. Reduce your fraction. 4 goes into both. So I get 2/3 for an answer on that one. Cool. Move on.
None of this stuff is on the quiz on Monday, right?
No. Oh, that's all done. Okay, so that would mean that worksheet 9F will be due on Tuesday. So now we're going to kind of, with a quiz on Monday, which is 9A through 9E. Okay, so we're going to do 2 things at once. So I need you to take the sleep survey. So the front person from each row, grab enough Chromebooks for everybody in your row, please. And let's get the word problem homework out. So I guess that would have been A, B, C, D. Yeah, D. And also let's get E out if you have any questions on E. Sound good? And we're going to multitask. So do the sleep survey best you can, and let's go over homework. Yes, ma'am.
These are all the ones from when I was gone.
You are awesome. I'll put those in.
All
I'll get those in the grade book for you.
sweet. Thank you.
Yeah.
Oh yeah, I still need to come in and. Can I come in 8 today and finish that?
Yeah.
Quiz? Okay. Thank you.
You want to hand me some computers just because you're a sweetheart, please? I appreciate it.
Okay, I am on worksheet D. Worksheet D. So everyone good on the assignment? Let's do. And I'm looking right now at worksheet D. Worksheet D. What questions did you come up on worksheet D? Number 9 on D? Okay. Okay, they tell us that it's about air pressure. H is the altitude above sea level. So they give us on number 9 this equation. Let's see, 14.7 raised to the, or e to the negative. Is that okay? So from there, what we're going to do is we want to know what's the air pressure at Mount Everest. So that means I'm going to have 2, 3, 4. I'm going to multiply the elevation at Everest, 29,028. So I would just plug that directly into your calculator just like that. And it's going to give you a number that's smaller than 14.7. And then the other one, so that's at Mount Everest. And then at Denver, being we are at 5,280, you're going to do this in your calculator and just plug it directly in. So again, just plug it directly in. Make sure when you plug it in your calculator, you have the negative as part of your exponent. Is that okay? What else from 9D would you like to see? And the sleep survey should have been emailed to you. Maybe it's labeled start time or something like that in your email. Or start time survey or something like that.
We do 7.
7, yeah.
We should start at 9.
Nope. 7. So as a computer value depreciates 23% annually, its current value is $2,500. How much was it worth 2.5 years ago? Okay, so I'm going to use this. I'm going to use that equation. The reason, remember that minus up there could be a plus if it appreciates or it increases. So they tell us that this current value is $250. So we're trying to find P. 1 minus the rate was 0.23 as a decimal. And then how much is it worth 2.5 years ago, so 2.5 years ago? So I would do this with this problem. So I'm going to figure out 1 minus 0.23 raised to the 2.5. So I'm going to go 1 minus 0.23. And that answer I'm going to raise to the 2.5 power. So I get 0.520. So once I figure out this here, .520 I said, okay. Times P, divide both sides by 0.520. 250 divided by 0.520. So your computer cost you $4 or $480.77, rounded up.
Who weeks ready to start the day?
You with that? What else?
The graphing of the last one.
The Latin.
14.
Do what?
Craig Whitgrove.
Could be Craig Whitgrove.
I got that from Craig Whitgrove.
Yeah. What other one did you want? I'm sorry. 14? 14. The sofa is worth $3,200, depreciates 8% per year. An antique table is worth $1,700 and appreciates 4% per year. Graph both to make it appropriate. Okay, so 14, we have a sofa that is losing value, and we have a chair or a table, excuse me, that is increasing in value. So we want to see when will they be worth the same amount. So the sofa costs $3,200 and it loses 8% per year. And we have a table that is currently worth $1,700 and it appreciates at 4% per year. Okay, so I'm going to create two equations. So y equals p, and then that's going to be 1 minus 0.08. And then, oops, that p value should have been 3,200. And that's raised to the x or the t. So we're going to graph that, and then this one, we're going to go y equals 1,700 because that's the price. And if it appreciates, I'm going to add 0.04 to 1. So 1 plus 0.04, and that's raised to the x. And I'm going to go ahead and graph both of those. So 32. 3,200. 1 minus 0.08. So graph that one, and then the second equation is going to be 1,700, and it appreciates. So 1 plus 0.04 raised to the x. And then I would probably hit zoom fit because it would probably show the intersection if you do zoom fit, which is zoom 0. So it does look like I can see the two of them intersecting. If I wanted to, I could maybe zoom out so I can see them a little bit better. Okay, so I'm going to go second, calculate. I want to find an intersection. And then the first curve is that equation. The second curve is that equation. So in 45 years, they're going to intersect. Do I have those right? 17 plus 0.04. 3,200 minus 1,700 plus. Yeah, that should be right. That good? I just verify the answer, see if I got that right. So 9D, they said. B, C, D, E, F, G, H, I, J, K. 9D. I'm just looking up the answer. 9D, number 14. They have 15.16 years. Why am I so off? There we go. So, yep, in 5 years they'll both be worth $2,081.26. Cool. Any questions from 9D still? Yeah.
12.
You said 12?
Yeah.
Okay. All right, 12. Use your graphic calculator to answer the questions involving 600 invested for X years at a rate of 3 point compounded quarterly. So we compounded quarterly, that's 4. My initial investment 600 and a rate at 0.033. So this is invested at quarterly, so A equals P, well P, and then parentheses 1 plus the rate over N to the NT. So I have A equals 600, 1 plus rate 0.033 over N, which is 4, raised to the N, and then N, which is 4, and then we're going to call that X. So I'm going to graph that. Y equals what? 600, 1 plus. 0.033 divided by 4. Oops. Zoom fit. All right. Maybe zoom out a little bit. Zoom out. All right. So we got that. It says graph in the appropriate window. So we have this. If you want to see what your window is, they're saying that's the window. Does that seem okay? Looks like the Y minimum. Oh my gosh, the Y minimum is, bless you, is a enormous negative number, and the Y maximum window is an enormous number because they're both to the 19th power, but that should be good enough to see. Use your calculator to find the value after 7 years. So if I want to calculate a value, I'm going to hit a value at 7 years. So at 7 years, it's worth $755.20. And then use trace, calc, intersect, or table to find the number of years when it's worth 720. So I'm going to plot a second line. So 720, which is a horizontal line. If I graph that, it's that red line. I don't know, maybe I want to zoom in a little bit. Bring this down here. Maybe bring it over a little bit. Zoom in again. And zoom back out. Zoom out. Alright, so they're going to intersect each other. So second calculate, intersection, enter, enter, enter. So at 5.5 years, this is going to be worth $720. Any other questions off of D? All right, go ahead and pass D on forward, and we're going to be looking at E, which is the review. I won't collect the review, but we'll go over any questions you might have on the review. But pass forward D. And you guys have found that sleep survey, I hope? Yeah.
Turn in D?
Yeah, go ahead and turn in D. Make sure your name's on it, please.
Hell yeah.
Yeah, bold's fine.
Turn in D. Can I come in on Monday if I come in?
Thank you, dear. Thank you, dear. Thank you, dear. And no one to thank here, but I'll call him dear anyhow. And you are also dear. You didn't know you were a dear, huh? See how we roll? Okay. So looking at the review, what questions do you have off of 9E? 9E.
Where do we find this sleep journal?
It's in your email, and it's called. It's called Start Time Survey or something like that. It's from Mr. Whitgrove.
I don't think it is from. It's not from Whitgrove.
No?
No, it says Cherry Creek School.
Cherry Creek
For me, man, I can't take it. Throwing in the towel.
What'd you have? Start time, end time. Start at 11, end at 11:15.
Yeah.
Okay. Those would be quick classes.
Just this class, bro.
We'll just make this class. All right. Hey, happy to teach you guys. I'd be happy to teach you guys pre-calc, calc. I guarantee I can take you through. I guarantee I could take you through calculus if we had time.
If you could do it, then none of us have to take help, and then just give credits for help.
Got it. You got an AP test to take. I do have a goal. One day I would love to do this. I would love to get a group of freshmen. I know they're freshmen. So freshmen, if they came in at Algebra 1, and then second year I would teach them Geometry and Algebra 2 both. They'd have me twice. Third year take pre-calc, and fourth year take calc. I would love to do that. Who knows? One day that might be something I might be able to do. I got 15 more years to do it.
It's a lot of teaching.
I think I got a couple more years left in me.
9 o'clock start time.
Any questions off the review? Does everyone feel comfortable?
Oh, thanks, Kate.
Yeah.
Since spring break is coming up, can you video the story of your search here?
You're not gonna be here?
They can't make it out.
Oh, that's too bad.
Like, I don't think they can, I look, there's one.
25% of the thing, like.
No questions off the review? We're good?
One of the equations, like making an equation.
I have a quick question. I need to finish that quiz.
Yeah, when do you want to do it?
That quiz?
Yeah. Yeah, if you'd like to do it today. I mean, if you need more time, that's okay. But
I feel like I need more time, but I'm probably not going to do anything over the weekend.
okay. So you know where to find me?
Yeah, I might.
I'm on the team, but like, I
Yeah,
have
that
to
works.
Don't
try out
be
with them.
It'll be like Monday.
I'm down the hall.
Okay, yeah.
First one.
It sucks because like, you know.
No questions off the review. We are set. We are happy.
I'm gonna be.
I do it, dude.
I lost
You
my
want-
shit.
It's like.
You want like one to come up with the equation?
Then we're gonna have
Yeah,
to-
the one that you have the graph, and it's like, what's the equation for the graph?
Like 25 through 28, like those?
Sucks.
Yeah.
I hate
All
that
right.
so much. You know, seconds, if you like, already got dedicated to your team. Yeah, the pasta dinner's gonna blow.
It's not.
Yes, it is, Kate. Kate, I'm over your positivity. I'm done with it. I don't fucking stroke. Thank you.
Chill, y'all.
No. I'm over it. I don't need your positivity. Don't talk about it. No, it wasn't fun last year. Everyone was crying. It was bad. Yeah, Kate. I wasn't either. But everyone else was.
Why would they class?
Because that day is when sophomore, freshman,
Like that one?
team.
Yeah.
People who said
Okay,
facilities
growth.
wanted to, they're all crying.
Yeah.
Right? All right, so I'm going to do two things. So I'm going to use my equation.
I know you did.
Oh, and we're gonna have this on the test, so we just
Yep.
have to plug in the number.
So you got here. So that's a distance of 1. That right there. So that's a distance of 1. That right there is a distance of 3. So it's growth. So it's my B value is going to be 3. Not worried about the A value. It's not shifting right or left at all. So I have to the X. Asymptote -2.
Oh, okay, so that's simple. And then we don't have to memorize any equations.
No.
Sounds good.
And we're not stretching it all, so we won't know what a vertical translation will be, so we don't have to worry about changing the A value.
Nice.
Well, because Brad's right.
No other questions? We're good? I can stop recording?
I'm so ready for this test.
Brad's really good.